All right. So, some of you may, in your math classes, or you may have seen my video of this, where a lot of people memorize it through learning the Pop Goes the Weasel song, right? Where it's negative b plus or minus the square root of b squared minus 4ac all over 2a. One more time for you if you want it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, so what does that mean? What does that mean? Why is it happening? What does it want from us? Why did it come here? Ooh, you brought coffee? Extra credit. Side story as I write the next part down. I had a student once who he'd always go to Taco Bell. Like he'd be late for class for like after lunch because he'd be grabbing Taco Bell. And I'm like, listen, kid, if you're gonna be late bringing in Taco Bell, I can be bribed to not mark you tardy if you just, like, brought me a cheese quesadilla, right? Maybe some chips and cheese. All I'm saying is I'm a dollar menu item away from marking you on time. So, you know what? Teachers aren't above bribery. Not for big things, but for little things. We can be bought. Mainly with food. Okay. So the quadratic equation is paired with this polynomial. We call it a polynomial because, well, this one can also be known as a trinomial because it's got 3. But it's a polynomial because it has more than 2 spots. And really a nomial is just like you've got one variable going through it, right? I have my x's going through it. It's okay. You are just vibing with me right now. Take a moment if you need to get this down. But this guy relates to this guy, okay? These guys are important. They go together. They're friends. They've got a long story together, and they get along. They're good. They're here to help each other out. They depend on each other. It's all good. They're just holding hands over here. Isn't that nice? That's so nice. They're besties. These guys are besties, okay? And if it helps you to make up a story, make up some lore about them. It's great. They're so good, friends. So basically, what this guy gets used for, and I'm going to take a step back in just a moment. So just everyone take deep breaths. You're just vibing with me. You're just trusting me on this guy, okay? This is how we line these up, and then I'll tell you what we're doing with them, okay? So what this means is whenever you have a letter in math, it's just standing in place for a number. It's just standing in place for. It's like if you were like in line to get popcorn and you're like, oh, I've got to go do something. I have to use the bathroom. Hey, friend, could you stand in line for me? That friend doesn't want popcorn. They're just holding your place, right? These are just placeholders for numbers. Letters are just placeholders for numbers. Honestly, we could be drawing fish or cats or the frickin' Batman symbol for all we care. It doesn't matter. It's just a placeholder, okay? That's all that is. Whenever you see a letter in math, don't panic. It's just a placeholder for a number. It's just saying, hey, chill for a bit. The number's coming back, okay? That's all. That's all. It's nothing to panic at. It's nothing to worry about. Even X. X is just a placeholder. It's just saying, yo, a number will be here soon. But like right now, I'm just holding its spot. And often when we use X and Y, it's relating to our XY axis that you see in a graph so that we can like make it a visual thing later. Okay? It's just there saying, yo, this could be a number. The number's coming back. That's all. That's all. It's okay. Don't panic. It's just chilling there, holding its place for a number. All right. So this kind of is standing in place for if I had, I don't know, I'm making something up on the spot here. If I had 2x squared plus 6, I don't know, x, I shouldn't have used 6 with the b, that looks too similar. 5 plus 3 equals 0. All that these are saying is that a would be equal to 2. We'd plug in 2 for our a's, right? A was just a placeholder for a number. And then 2 came back and we were like, hey, cool, 2, take your place in the thing. That's all. B was standing in place for 5 in this situation. So we'd be like, bye, B. Bye. 5's back. And we'd plug 5 in. And then we'd look and be like, oh, hey, C was just standing in place for 3. That's chill. All right, C, you can move over. We're going to plug 3 in now. That's all the quadratic equation is. That's all variables are. It's just holding the place for when the number comes back. And here we have it where we just line these suckers up and go, okay, A is 2, B is 5, C is 3. Y'all can go home. We got the real numbers. And once you got them numbers, you just plug and chug. Yes, it's that easy. It's that easy. It's not that bad. We look at it and it looks big and scary, right? It looks so big and scary. It's not big and scary, though. Hard math is honestly just easy math stacked upon each other, wearing a trench coat, trying to get into an R-rated movie. That's all. You take away that trench coat and you're like, oh, hey, you're just easy math stacked on top of each other. It's just doing easy math a bunch of times. That's all. It's actually simple. All hard math is actually simple. It's just doing simple math a bunch of times. But it looks big and scary, right? This looks so big. It looks so scary. It makes us want to cry. It's not that bad. It's never been that bad. So yeah, keep that in mind. When you see big things in math, when you see numbers and letters and you're like, like it's not that bad. It's just easy math stacked on top of each other in a trench coat, trying to get into an R-rated movie, trying to pass as an adult. Okay? Take away the trench coat, unstack the things, do them one at a time, and it's okay. Okay? All right. Your mom sent you this? That's beautiful. She was like, do math. I kind of love that. All right. So here's what this math is actually getting at. Let's take a step backwards. I kind of threw you in the deep end and now I'm plucking you out and I'm going to go, okay, let's look at what this actually is doing. Because if we don't know why we're doing the math, what's the point of doing the math, right? There's no point in it. So let me pluck you out of the deep end of the pool after I dunked you in, went, hey, look, it wasn't that bad. You got your face wet. And now we're going to explain what it is. Also, that metaphor comes from my first job was a swimming teacher instructor, right? I literally had the little kids and I dunk them in the deep end and go, oh, look, it wasn't that bad. Now we can get started. And they'd cry and I'd put them on the side of the pool and give them a toy and go, you're going to be okay. We're okay. See, you're okay. And they're like, oh, wait, I am okay. That's what I just did. All right, so I'm going to erase this. And then we are going to talk about why would I use a quadratic equation? Great, that's a quadratic equation. Great, it's not that hard. But why? Why quadratic equation? What does it want from me? Why is it useful? Why is it not going away? Why did it beat me up and steal my lunch money? Right? Yes, it's to find the roots of a polynomial. Killing the game. I love it. What does that mean, though? What does that mean? What does that mean? What does it mean? What does it mean? All right, so let's erase this and talk about it. Talk about it, talk about it. Ooh, yeah. Erase. Ugh, where's my husband when I need him? I'm kidding. I only have bad jokes. It's like an ongoing thing in my classroom right now for my students to steal the erasers from my boards and hold them hostage. Like with ransom letters and everything. Kids be extra. Ugh. And that's why I love being a teacher. I'm gonna lift this up a little bit more so we can get the whole board. Yay! Okay. Yay. I just got the question of what's a polynomial. Give me a second and I'll tell you. Protein bar. Okay. So, quick backwards thing. Someone asked, we're dealing with polynomials here. Sorry, I'm eating food. Let's talk about what a polynomial is. Let me give you a way that you're never going to forget it, okay? This is a binomial. Why do we call it a binomial? Well, it has the suffix bi. Now, when I call it a binomial, the word bi doesn't just mean you like boys and girls, okay? Bi also just means two. And we call it a binomial because it's got two spots. Two things in the equation. It's a binomial. Bam. Math. Yeah, like bicycle. It's bi. It's got two. It doesn't just like boys and girls. All right, but if we take the same analogy then, what do you think a polynomial is? Where have we heard the word poly? A polynomial has more. This one has three. So it's a polynomial, right? Poly doesn't just mean you're in a relationship with more than one person. It means it's got more than two things in it. Polynomial. Bam. Try forgetting that one. I told that one to some students, and one kid laughed so hard they needed to go to the bathroom. They were crying. Also, this is why I love teaching high school, because I can make those jokes. Woo! My beautiful hair is in the way. Yeah, tell that one to your teacher. See what they do. That'll be funny. Binomial, two. Polynomial, more than two. All right. So, I'm going to draw a graph. Ooh, graph. Ooh. Get a visualization of a polynomial. All right? Let's do that. This is my x-axis, and this is my y. Tell me why. Let me erase that a little bit so we can tell. All right. And then this is a parabola. Ooh, sick parabola, bro. My marker's dying. I need new markers. Let's see if this one's better. That's a little better. Great. So, what the quadratic equation does is it helps me, someone said it helps you find your roots, right? Yeah, sick parabola, bruh. Someone said it helps you find the roots of a polynomial, all right? Whenever you have x squared in your thing, right? Like, that's the biggest part of your polynomial. That's the most x's you have. So, like, I'd say I've got x squared, I don't know, plus 2x plus 3. This isn't what this one looks like, but all x squareds look like They look like a U, either a frowny face or a happy face. All right? What we're trying to find with the quadratic equation is we're trying to find this and this. We're trying to find the spots where that sucker hits the x-axis. Why? Why would that be useful? Why would we want to know that? Imagine this as anything launching up in the air and falling back down to earth, right? It's going burp, burp, right? Interesting things happen there. It is very useful for me to know where the launch starts, and when that sucker is going to hit Earth again. That's very useful information, right? This can be used in evil ways or really cool ways, like with rocket launches and stuff. That's what it is. That's what the quadratic equation does for us, is it tells me where the heck that is. That's so neat. They made a whole equation for it. Huh? Your brain is coming back. I love it. That's all it is. That's what the quadratic equation does for us. It tells us where those spots are. So nice of it. So nice of it. All right. So, we're going to take this back now, and we're going to try the quadratic equation. We're going to try, if I gave you an equation, if I gave you the path in which something traveled, could we find where that thing started at the ground and where it ended? Could we find its zeros, where it hits there, okay? We're going to do that. And remember, if your brain hurts, that's a good thing. We always act like it's a bad thing, right? We always act like it's a bad thing for us to be doing math and our brain hurts. That must mean we're dumb, right? Wrong. That means you are pushing yourself. That means you are learning something. That is literally your brain. Oh, I like that. Thank you, honey. That is literally your brain growing. That's what that's feeling like. Your brain is this whole thing that it grows, it learns, it makes literal new connections. You wouldn't go to the gym and lift weights and go, oh no, my arms hurt, I must be weak. No. You go to the gym and you leave not feeling like you worked out, people are going to be like, wow, you didn't do a very good workout. Why is it different with learning? Your brain is literally growing. That's a good thing. You are doing better than everyone else who doesn't feel that burn because you're pushing yourself. And I am so proud of you for that. Okay, let's do this. I had a dream last night. Like, I sing a lot in class, like I do here. And I had a dream last night that a student told me it was really hurting their education for me to sing, and they needed me to stop. And that I woke up very sad. Okay, I'm going to put the quadratic equation back up on the board. I'm going to put the little thing that helps us cheat to figure out like the setup on what's A, B, and C. And then I'm going to put up an equation, and we're going to plug and chug. We're going to use this equation, okay? We're going to find them zeros. We're going to find the roots and where it hits on that graph. All right, let's do it. Let's do it. Yeah, you can take notes. I encourage that, honey. You do what you need to do right now. All right? Okay. So, quadratic equation again was negative b plus or minus the square root of b squared minus 4ac all over 2a. Why is it set up like that? Why is that the quadratic equation? That's such a good question. I don't know. Okay. And then we've got that our equation should look like a times x squared plus b times x plus c equals 0. The equals 0 is really important. Falling over. The equals 0 is super, super important because that's saying that, like, that is, you know, my graph, if I go back to it, and we're saying, oh, that's where it hits the x-axis. That 0 is important because the x-axis is where y equals 0. So that's telling my equation, that's telling me that I'm looking for it at that spot. Okay? So that's why the 0 is really, really important. Cool. All right. I made an equation. I'm going to pop it up on the board. We're going to try it out. We're going to live our life. Sick. I've got x squared plus, is it a plus? Yep. 3x minus, oh my god, there's a minus 10 equals 0. Great. That's the equation that I'm going to find the roots of. Got no roots for my home was never on the ground. Okay, I'll stop. Yes, you're so smart and beautiful. A is 1. Because if I have nothing here, and I was about to say that. I was about to say it. Yes. If I've got no number here, anything times 1 is itself, right? If you ever see no number, it's a secret 1. So let's put that in there. All right. So, following this, I have A equals 1. Yep. A is 1. A is just, in this equation, holding spot for 1. B, well, that's 3. And now here with C, since I have that minus, that just means that C is equal to negative 10. Great. Oh, I love to see it. You love to see it. Honestly, it was easy the whole time. We like to treat math like it's hard. We like to treat math like it's something that not everyone can achieve, right? It's this weird placeholder for us, but everyone can achieve it. Sometimes you just might have to do it in your own time and your own pace, and that's okay. It's okay to do things at your own time and pace. But you're capable of it. And even if you don't get it right now, that doesn't mean you can't go back to my YouTube channel and watch this again and see if you can get it later. It's okay for it to take multiple times. But it's not that bad. And you're going to be okay. And you're capable of this. And I honestly, from the bottom of my heart, believe that. And I say that as someone with a learning disability. Okay? I believe in you. All right. So I've got what the A, B, and C should be. So now all I'm going to do is I'm going to take my equation and we are just going to plug in what the things are. Okay? We're just going to plug it in and solve it out. Woo! Plug 'em in, plug 'em in. I think only my 90s people got that. Because I tried to use that in class recently and people were like, what are you talking about? All right, so we're just going to redo this equation. I'm going to write, here's what I'm going to do. I'm going to rewrite the equation with the letters down here again, but then I'm going to erase them to show you that I'm plugging them in, okay? Just to really emphasize that. So that's what I'm doing. I'm just rewriting the quadratic equation down here, and I'm going to erase them as we plug them in. All right, we're going to start with A. I'm just going to erase all my A's and plug a 1 in. That's all I'm doing. That variable, that letter, was just standing in place for a number. We know the number now, so we're just going to erase it, okay? We're just going to plug it back in. A, you are now 1. We're going to take all my A's, and they're now 1. Beautiful. So this is now 2 times 1. Be careful not to just write 21, okay? You're a 1. The parentheses just mean multiply, okay? Parentheses just mean multiply. I know we got a billion ways to write multiply, and it sucks, but that's life. That sucks, but it's life. All right. Now I've got B is 3. I'm just going to take all my B's, and I'm going to erase them, and I'm going to plug in 3. You are now 3. Great. Now I've got my negative 10 for C. I'm going to erase. And I am going to plug in negative 10. Again, putting my parentheses to emphasize that it is multiplying. Otherwise, I could get confused and do the wrong thing. So this is what we end up with. And now, to save room on my whiteboard, as we solve things out, I'm just going to be erasing and plugging it in. What you should be doing is just rewriting the whole thing as you go, okay? For each step that we do, we are just rewriting that, okay? Also, shout out to my beautiful mods who are keeping the chat safe and wonderful. Love you. It's so much easier. Yay! That's what I love to hear. All right, let's do this. We're just going to, and again, like I said, sorry, I'm stepping in front of here, but I only have a little bit of space. Like I said before, hard math is just easy math stacked upon each other in a trench coat trying to get into an R-rated movie. All right, that's all it is. So as you look at this guy and go, well, that's a lot happening. That's big. That's scary. That's a lot going on. Back up. Hold on. It's not that bad. You know how to do all that. You know how to do all that. It's just a lot. Right? It's just a lot. And we're going to break it off into tiny bite-sized pieces so that we don't choke and die. That was a great metaphor. But we're just going to take it piece by piece. We're not going to try and do the whole thing at once. Don't do that. No one can. Okay? We're just going to take it piece by piece. We're just going to unstack them and tell them that they can't get into the R-rated movie. Okay? Great metaphors. That's all I have. All right, let's go. All right, so I'm going to start with this 3 squared. Why? Because I am. Great explanation. So, what's 3 times 3? What's 3 squared? Because squared just means times. Yeah, you can use a calculator. I don't care. 3 times 3. And be careful that you're not doing 3 times 2 or 3 plus 3. It's 3 times 3. Nice. Beautiful job, my dears. It's 9. We're going to erase this guy. Again, you should be rewriting it, but I don't have much room, and I have a whiteboard, so I'm just going to erase it. This guy is now 9. Great. I'm going to come down here and do this one. Why? Because it's easy, and I like that. What's 2 times 1? Yeah. 2 times 1. It's just 2. I'm just going to erase this 1. Kind of re-emphasize my 2. Awesome. We got a 2 down there. Come on. Come on, work with me. All right, now I've got this dude where it's like three things multiplied by each other. We're just going to do it one at a time, okay? I'm not going to try and do them all at once. I'm just going to do one at a time. All right? I'm going to do this 4 times 1. That's just 4. So we'll get rid of the 1. 4 times 1 is just 1. Bam. All right, now I've got this. I like to treat this as like a negative 4, and here's why. You can write it as -4, or you can do plus a -4. Those are the same thing. So -4 times -10, negative times a negative is a positive. Negative times a negative is a positive. -4 times -10. You guys are so smart and beautiful. It's 40. Boop, 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 boop. Running out of things. So this ends up being plus 40. This is already starting to look so much better, isn't it? We're just cleaning this guy up. It's like a dude that looked really rough and we're like cleaning him up for his date. That's such a bad metaphor. Yeah, beautiful. It's going to be 49. 4 plus 9 is 49. Yes! All right. So we're going to put this guy in as 49. All right, and those of you who have been here with me for a while, remember my lesson on square roots, yeah? If you haven't seen it, you can go to my YouTube channel and look it up. I do a whole thing on square roots. The square root of 49. When I do a square root of 49, I'm looking for what number times itself gives me 49. What times itself gives me 49. Kind of like how 2 times 2 gives me 4. So what times what gives me 49. Awesome. Beautiful. You guys are so good at this. It's 7. The square root of 7 is, rewind. The square root of 49 is 7. 7 times 7 gives me 49. A square root is the same number. It has to be the same number to get that middle dude. And if you want to know why that is, again, go to my YouTube channel. We don't have time to unpack all of that right now. You can see that video, though. So this guy's 7. Oh, this is looking nicer and nicer the more we do this. We're cleaning him up so good. All right, here's the part. Here's the part where it gets a little confusing. So clean, so nice. He's getting all nicely shaven. We're styling his mustache out. He's looking more and more presentable. All right, do you guys remember when I showed you the graph earlier? And it had the 2 spots we were looking for, right? The spot where like it started and then where it ended, right? Where it went and hit the x-axis. There's going to be up to 2 answers. Okay? That's why we have this plus or minus. So when you get it, it's by. Exactly. Yay! Multiple uses for the same metaphor. All right, when we get it to this point, we're actually going to split it up into 2 problems, okay? So we're going to split this guy up into 2 problems. We're going to do one with the plus and one with the minus. That's what the plus or minus means. So it was secretly 2 problems the whole time. So that we can get 2 answers. Oh my gosh. So we're just going to -3 plus 7 over 2. And -3 minus 7 over 2. That's what that means. Okay? We just have 2 to work with. Ooh. I liked what you said either, but the answer is and. All right, let's go. So, -3 plus 7. -3 plus 7. That's going to be 4. Erase that. It's 4. What's 4 divided by 2? 4 divided by 2. Yeah, buddy! Nice! It's 2. One of my answers is 2. Bam! All right, now we go to this guy. He's ready for his date. Let's get the other one. -3 minus 7. -3 minus 7, what is that? Well, -3 minus 7. Ooh, I'm seeing some really good answers. I'm also seeing some really good wrong answers. And the reason why I say really good wrong answers is that there's something right about what you're doing when you do something wrong. And that's kind of cool. All right, -3 minus 7 is going to be -10. -10 divided by 2. Yeah, buddy, I'm seeing it. -10 divided by 2. You should feel smart. Awesome, it's -5. We did it! Yay! These are my 2 answers. So to give us a slight visualization of what we just found, a slight visualization of what we just found. If I have my little graphy graph, right? I got my little graphy graph. This guy's actually going to like be shaped like this, where he's going to like open upwards. We're not going to get into that right now. But this guy kind of looks like this, where this is -5 on my graph, and this guy is 2 on my x-axis. That's what we found. We found those 2 spots. We were like, hey, this equation, where do you touch the x-axis? And it was like, yo, buddy, right there and there. And we were like, that's cool. That's what happened. No, the y was 0. That's why we had it equal to 0. Because y is 0 at this point. Good question. That's what that is. Yeah. It all came together. Mwah, ha, 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 ha. Mathematical. All right, to recap what we did. We took our beautiful, wonderful quadratic equation, which looks big and scary, but it's just there to help us out, man. It's just there to help us out. It's just there to help us out. It's okay. We took the basic setup of our equation, which is that this guy, this guy has the A, this guy has the B, this guy has the C. We took our equation and we went, oh, hey, this equation means A is 1, B is 3, C is -10. And then we just took that, plugged in all of our numbers all of our letters for the numbers, and then we solved it out. We cleaned it up piece by piece, and we got our answer. It wasn't that bad. It was a lot. I'm not going to lie. It was a lot. It was a lot of steps, right? It took a bit, but